Chemical bonds. So chemical bonds involve the sharing and the gaining and losing of electrons in the valence shell, the outermost shell. There are three major types of chemical bonds that we'll be looking at. Ionic bonds, which is the attraction between cations and anions. Cations are the electron donors, they give away an electron, and the anions need an electron and they take an electron. Then you have covalent bonds, which is the strong electron bonds involving shared electrons. And the final one that we'll be discussing is hydrogen bonds, which are weak polar bonds based on partial electrical attractions. But I'll go through that more in a moment. So chemical bonds. It's formed from molecules. Chemical bonds form molecules and or compounds. So molecules, two or more atoms joined by a strong bond. So whereas a compound is two or more atoms of different elements joined by either strong or weak bonds. So a molecule is two or more atoms of the same element, whereas a compound, just as it said, is a compound of two or more atoms of different elements. So compounds are all molecules, but not all molecules are compounds. For example, if we look at the hydrogen, it is a molecule only. But if we look at hydrogen plus oxygen, that is a molecule and a compound. Let's look closely at ionic bonds. One atom, the electron donor, loses one or more electrons and becomes a cation with a positive charge. Another atom, the electron acceptor, gains those same protons and becomes an anion with a negative charge. So because the first one has lost an electron, that means it becomes more positively charged, and the second one has accepted the electron, that means that it has more of a negative charge. And we know that opposites attract, so the positive and the negative attract each other and the two ions join together. So let's look at this diagram. So starting on the left with number 1, the formation of an ion. So here we have the sodium atom. Sodium in the middle with the valence shell around the outside. You can see the first electronic shell is balanced. The second one is balanced because it has 6, but the outermost only has 1, so it's not balanced. If we look at the chlorine atom, we've got the innermost shell balanced with 2, and then we have 6, and then on the outside we have 7. So it's wanting one more to complete its valence shell. So it means that the sodium, if we move now to the second drawing, the attraction between the sodium, which is now positively charged, and the chloride ion, which is now negatively charged, causes an attraction between them, and they form an ionic compound that we know as salt, sodium chloride. So let's look at it. Here is a sodium chloride crystal with a large number of the sodium chloride ions forming a crystal of sodium chloride, table salt. So that was ionic bonds. Now we're looking at covalent bonds. Co, because they share. Covalent, the sharing of pairs of electrons between atoms. One electron is donated by each atom to make a pair of electrons, and they share one pair of electrons, and that is called a single covalent bond. If they share 2 pairs of electrons, that's called a double covalent bond, and the sharing of 3 pairs of electrons is a triple covalent bond. So let's have a look at a diagram of that. So here we have the molecule being hydrogen, oxygen, carbon dioxide, and nitric oxide. And then the diagram shows the electronic shell model and the structural formula. So if we look at hydrogen, we have 2 electrons that are drawn together and they share each other and then they balance out. If we look at oxygen, you can see that the innermost shell with 2 each is balanced, but the outside shell has a balance of 6. So each of them have 6, and together they will have 8, which means that their valence shell is balanced. So that's why they're attracted to each other. Carbon dioxide, so we have 2 oxygen and 1 carbon dioxide in the middle. Similar sharing occurs so that they can reach a balance. And then nitric oxide, we've got the nitric and the oxygen, and they join together also so that they can balance each other. Covalent bonds can also be polar and non-polar. When we talk about polar, we mean like the poles, where we have a positive and negative charge on a magnet. So non-polar covalent bonds involve equal sharing of electrons, because the atoms involved in the bond have a pull together to form a full level of electrons. Polar covalent bonds, on the other hand, involve unequal sharing of electrons because one of the atoms involved in the bond has a disproportionately stronger pull on the electrons. Water is an example of a polar molecule. Let's look more closely at this. So water, we know, is 2 hydrogen atoms and 1 oxygen atom. We know that hydrogen each has 1 proton and 1 electron in its valence shell. And we know that oxygen has the valence shell where we've got the balance, and then we've got 6. So it's wanting to complete its valence shell with 8, and so it's attracted to the hydrogen, which joins it, but it joins it at one side. So you can see that one side of it is more positive and the other side is more negative. So that means that it is polar. Hydrogen bonds. Now the final one, hydrogen bonds between 2 adjacent molecules, not atoms, involve slightly positive and slightly negative portions of the polar molecules being attracted to one another. Hydrogen bonds between water molecules cause surface tension. Sorry about that. And surface tension is important when you're measuring out medications. So you want to look at the bottom of the meniscus if you're pouring medication into a medicine cup, which is a liquid. So here we can see the hydrogen bonds between water molecules. So the positive and the negative ends of the polar molecules are attracted to each other. Now, molecular weights. Molecular weights of a molecule is the sum of the atomic weights of its component atoms. So hydrogen has approximately 1, oxygen has approximately 16. 2 atoms of hydrogen have approximately 2. So together, if we add the oxygen and 2 hydrogen together, we get approximately 18 being its molecular weight. Looking now at states of matter. Solid, something solid, if you look at an ice block, has a constant volume and shape. Liquid has a constant volume, but it changes shape. Gas changes shape and volume. So that's enough information about basic chemistry. So I'll finish this lecture now. So those of you who are up with chemistry will find that as basic revision. Those of you who've not had a chance to be involved in any chemistry will need now to go back and revise. In Mastering Anatomy and Physiology, there is the study aid that you can access, and in particular I would refer you to the chapters in Getting Ready for AMP, which you have access to. That provides very clear descriptions of the basic chemistry that we've just covered. I'll see you in a while for part 2 of this lecture.